See care in a new light at Madonna Rehabilitation Hospitals, where top medical minds lift you up, where the very best in specialized rehabilitation brings out your very best, where over 60 years of breakthroughs in research and technology spark your newfound strength. In our world-class hospitals, this is something greater than rehabilitation. It's renewed strength for life. Learn more at madonnarehab.org.
Welcome everybody, it's another episode of Astronomy Daily. I'm Steve Dunkley, your host, all the way from the east coast of Australia, down under. It's the 26th of June 2023.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And with me as usual is our digital assistant, Hallie. Welcome aboard, Hallie.
Hello, everyone.
Yes, always great to have you here.
What's on the menu today, Steve?
Well, there's a great story about Rocket Lab and their plans for a new launch soon.
That's next month in New Zealand, right?
Yes, that's right. And there's also been a call for something to be done about the growing mess of orbital debris.
That would include old inactive satellites, spent boosters, and even tiny bits and pieces.
Yes, every little piece is a hazard to future missions.
I was thinking about that while watching the Russians dump things off the ISS the other day, which seemed strange. And I've got a story about a super hot celestial body that's breaking some records but could use a proper name before it gets eaten by a sun.
Oh, well, that one sounds really exciting.
I'll get into it then.
Okay, Hallie, all yours.
Rocket Lab USA reports that its next Electron mission will deploy 7 satellites to space and include an attempt to recover the rocket's booster after launch. Rocket Lab's 39th Electron launch, dubbed the Baby Comeback mission, is scheduled to deploy from the Rocket Lab Launch Complex 1 in Mahia, New Zealand on July 14 UTC. Rocket Lab is also planning to conduct a marine recovery of Electron's first stage as part of this mission. Their recovery team will retrieve Electron using a customized vessel and transport the stage back to its production complex for analysis. The Baby Comeback mission is a rideshare mission and will carry satellites for multiple customers. Rocket Lab founder and CEO Peter Beck said, "This mission demonstrates Rocket Lab's ability to provide responsive space capabilities on accelerated timelines, by making access to space possible for customers when they run into roadblocks." Payloads aboard the Baby Comeback mission include: NASA's Starling mission is a 4 CubeSat mission designed to test technologies to enable future swarm missions. Spacecraft swarms refer to multiple spacecraft autonomously coordinating their activities to achieve certain goals. Starling will demonstrate technologies for in-space network communications, onboard relative navigation between spacecraft, autonomous maneuver planning and execution, and distributed spacecraft autonomy. Spaceflight Laboratory selected Rocket Lab to launch Telesat's Low Earth Orbit 3 demonstration satellite that will provide continuity for customer and ecosystem vendor testing campaigns following the decommissioning of Telesat's Phase 1 Low Earth Orbit satellite. And Spire Global will launch 2 3U satellites carrying Global Navigation Satellite System radio occultation payloads to replenish its fully deployed constellation of more than 100 multipurpose satellites. Spire's satellites observe the Earth in real time using radio frequency technology. The data acquired by Spire's payloads provide global weather intelligence that can be assimilated into weather models to improve the accuracy of forecasts. A weird super-hot celestial body is breaking records and challenging astronomers' understanding of the boundary between stars and planets. The object, called WD0032-317b, is a brown dwarf. That's a mouthful. What would you have called it, Steve?
Maybe Darren?
Typical. Anyway, it's a type of bright, gaseous protostar. Brown dwarfs typically have a similar atmospheric composition to Jupiter but are 13 to 80 times larger. At that mass, these objects begin to fuse hydrogen isotopes in their cores. However, they aren't quite massive enough to spark the kind of full self-sustaining stellar fusion that powers stars like our Sun. Think of smoldering charcoal rather than a lit wood-fired oven. Brown dwarfs usually burn at around 4,000 degrees Fahrenheit, 2,200 degrees Celsius. That's fairly cool compared with most stars, whose surface temperatures reach about 6,700 Fahrenheit, 3,700 Celsius. But WD0032-317b, which is 1,400 light-years from Earth, is not like most brown dwarfs. In a paper published accepted by the journal Nature Astronomy, researchers measured the object's surface temperature and found it was a blistering 13,900 Fahrenheit, 7,700 Celsius. That's hot enough for the molecules in its atmosphere to fall apart into their component atoms. It's also several thousand degrees hotter than the surface of our Sun. This should be impossible for a brown dwarf. But the researchers discovered that the object got an assist from the star it orbits. WD0032-317b is extremely close to its Sun, an ultra-hot white dwarf star, so close that its year lasts just 2.3 hours. That proximity means WD0032-317b is tidally locked, with one side forever facing its star while the other faces away, according to Science Alert. Because of this, the brown dwarf is only superheated on one side, even though its day side temperature reaches 13,900 F. Its night side is a comparatively balmy 1,900 to 4,900 Fahrenheit, 1,000 to 2,700 Celsius. That's the most extreme temperature differential astronomers have measured on a substellar object, according to the researchers. But these conditions won't last long, as its molecules continue to fall apart. The brown dwarf is actually being evaporated by its host star. Research on objects like WD0032-317b could help scientists understand how hot stars slowly consume their companions. It can also add to the growing body of knowledge about the conditions that stars need to ignite. And I'm sorry, Steve. I don't think Darren will cut it as an official name this time. The European Space Agency, Airbus Defence and Space and Thales Alenia Space demonstrated their commitment to promoting the safety and long-term sustainability of space operations at the Paris Air Show 2023 Thursday. Satellites in orbit underpin our modern lives. They are used for space science, Earth observation, meteorology, climate research, telecommunication, navigation, and much more. But swirling fragments of past space endeavors are trapped in orbit around Earth, threatening our future in space. Over time, the number and mass of these debris objects grow steadily, boosting the risk to active satellites. Encouraged by its member states to implement a zero-debris approach for its missions, and to encourage partners and other actors to pursue similar paths, ESA is updating its internal space debris mitigation standards. We are calling upon all stakeholders from across the European space ecosystem, including new space actors, to display a strong commitment towards achieving global leadership in space debris mitigation and remediation, through the Zero Debris Charter Initiative, said ESA Director General Joseph Ashbacher. The Zero Debris Charter aims to bridge previous ESA initiatives aiming to shape global consensus on space sustainability, and the agency's technical work on the technologies and solutions enabling safe and sustainable space operations.
It's the Astronomy Daily podcast with Steve Dunkley.
Thanks again for joining us on Astronomy Daily. I'm Steve Dunkley, your host, and don't forget you can catch up with all past episodes of Astronomy Daily and our parent podcast, Space Nuts with Andrew Dunkley and Professor Fred Watson at this address, spacenuts.io. Now here's an interesting story, not for the faint-hearted I would imagine. Astronauts aboard the International Space Station have achieved a 98% water recovery rate in a breakthrough achieved by a method that might make the faint of heart a little bit squeamish. They hit the peak, oh dear, astronaut P recycling. Yes, the water recycling achievement is an important milestone for low-orbit space missions that aim to provide the basic needs of us astronauts without resupply missions. This means recycling or regenerating things like food, air and water. In terms of the International Space Station, each crew member needs about a gallon of water each day for drinking, food preparation and hygiene uses like brushing your teeth. The ideal goal in terms of water has been 98% recovery of the initial water that crews take into space with them at the start of longer missions. This is a very important step forward in the evolution of life support systems. Part of the team at Johnson Space Centre that manages life support systems on the ISS, Christopher Brown, said in a statement, "Let's say you launch with 100 pounds of water and you lose 2 pounds of that, and the other 98% just keep going around and around," he said. Keeping that running is pretty awesome, and it's quite an achievement. The water recovery milestone was achieved by the Environmental Control and Life Support Systems, that's ECLSS, during a demonstration of the improved urine processor assembly, UPA, which recovers water from urine using vacuum distillation. I don't even want to imagine what that is. The ECLSS is made up of a combination of hardware, including a water recovery system that collects wastewater and advanced dehumidifiers that capture moisture from the air of the ISS as a result of crew's breath and sweat. This collected water is sent to the water recovery assembly, which then produces drinkable water. The UPA element of the ECLSS distills urine, but brine is produced as a byproduct of this process, and that still contains some unused water. A brine processor assembly was added to the UPA to extract this remaining wastewater. While demonstrating its operations in the microgravity of space, the BPA pushed the ECLSS to the 98% goal, reaching that record. Like the other collected wastewater, this is treated by the WPA with a series of specialised filters and a catalytic reactor that breaks down any trace contaminants that may remain. Sensors then check the purity of the water that doesn't meet this with standards, sent back for reprocessing. Iodine is added to acceptable water to prevent the growth of microbes, and the water is then stored for the crew to use at a later point. So this raises the question, are our astronauts drinking urine in space? Well, the answer is an emphatic no. The team points out that in fact the water produced aboard the ISS is superior to the municipal water systems produced here on Earth. The processing is fundamentally similar to some terrestrial water distribution systems, just done in microgravity. Williamson points out the crew is not drinking urine, they are drinking water that has been reclaimed, filtered and cleaned such that it is cleaner to the water that we're drinking here on Earth. We do have a lot of processes in place and a lot of ground testing to provide confidence that we are producing clean, potable water. The less water and oxygen we have to ship up there, the more science that can be added to the launch vehicles. Reliable, robust, regenerative systems mean the crew doesn't have to worry about it, and we can focus on the true intent of their mission. Now, while NASA's Jet Propulsion Laboratory is renowned for piloting rovers on Mars and deploying spacecraft to study planets in the solar system, their latest project is more down to earth, assembling the world's largest publicly available archive of PDFs for security research. PDFs are a most popular form of digital document in the world, and while they might look like scanned copies of paper documents, they're actually collections of texts, images, movies and active scripts that aren't as secure as they should be given their ubiquity. To address this concern, JPL has partnered with the non-profit PDF Association to develop a new archive of files that will help researchers analyse potential threats across a wide library of real PDFs. The project involves assembling roughly 8 million PDFs, totalling more than 8 terabytes of data from various online sources. The effort is part of a Defence Advanced Research Projects Agency (DARPA) initiative called Safe Documents, or Safe Docs, which aims to make digital documents safe from malicious code and other security concerns. PDFs are used everywhere and are important for contracts, legal documents, 3D engineering designs and many other purposes. I can tell you that as a graphic designer, I use PDFs in my daily work, providing proofs of artwork and also finished artwork to all sorts of publications, and they are a very accurate way of providing your artwork, and they are cross-platform compatible too. So Tim Allenson, a JPL data scientist, said in a statement, "Unfortunately, they are complex and can be compromised to hide malicious code or render different information for different users in malicious ways. To confront these and other challenges from PDFs, a large sample of real-world PDFs need to be collected from the internet to create a shared, freely available resource for software experts. Using the freely available Common Crawl public repository of web crawl information as a starting point, JPL researchers identified PDFs to add to the collection, including those that were incomplete due to Common Crawl's download limit of 1 megabyte per download file. JPL then assessed those PDF URLs directly to download the full documents, ensuring a fully representative archive of the types of PDFs accessible on the web. By making the collection available to the public, JPL hopes researchers will be able to use and analyse the PDFs to identify better ways of securing the information these documents contain. You can see why it would be important to make documents secure, especially ones containing sensitive information. It's going to be interesting what classification of documents they come up with. And just like that, another episode of Astronomy Daily spins out of control and ends for another day. Thanks for joining us, everybody. Lovely to have you with us, and we'll see you again next Monday for another episode. I'm Steve Dunkley, your host. Don't forget you can catch all the past episodes at spacenuts.io, and don't forget all these past episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson can be found at that address as well. See you next time. See you, Hallie.
Catch you next time.
Bye for now.
Astronomy Daily, the podcast, with your host, Steve Dunkley.